Hi everyone, Mr. Markwick here. In today's video, I'm going to show you how to use a graphics calculator to determine probability of data being above or below or in between two data values when the data is normally distributed. Now, a previous video in this playlist, we looked at an introduction to normal distribution, and we were determining probabilities based on those values being exactly either on the mean or 1, 2, or 3 exact standard deviations above or below the mean. And we're using this graph here, which breaks down those percentages for us, or also known as the approximate 68, 95, and 99.7% rule. Today, however, you'll notice that when we're looking at these data values, they don't exactly fall 1, 2, or 3 standard deviations below or above the mean. So we're going to use the graphics calculator to determine the probability that the data is within a certain range, or the percentage of data, I guess, above or below or between certain values. So let's look at this example here. Suppose the weights of radishes in a field are normally distributed with a mean of 40 grams and a standard deviation of 10 grams. So I've just sort of shown that here on a bell curve where my mean is 40 grams. And you can see that each standard deviation I go up, I'm adding 10 grams, and each standard deviation I go down, I'm subtracting 10 grams. So you can see there are 3 standard deviation steps above the mean and 3 standard deviation steps below the mean, as always. So look at the first question here. It says to find the probability that a selected radish is between 37 and 48 grams. So on my bell curve, I'm basically looking at, what's the probability that between 37, which is approximately, in fact, let's use a color for that, is approximately here-ish, 37 grams, and 48, which is approximately here. What is the probability that a randomly selected radish will be in that region? Now, look, it's not on an exact standard deviation boundary, so we're going to use our graphics calculator to determine this. And I'm going to show you how to do that right now. So on your graphics calculator, we will be using that stats function again. So hop into that stats function as always. And rather than putting data in a list today, we're actually going to be going through this process. So click on F5 when you've got this screen up. So you've got graph in the bottom left-hand corner. We're not clicking on graph, F1. We're going to be clicking on F5 here, DIST. Then F1 for normal distribution. And then we're going to use NCD function today. So F2. Here, we're not using data from a list. We're putting in some variables. So change from list data to variable. And that way we can then put in the mean and standard deviation that are given to us in the question. So remember, this little U looking symbol is the mean, and this little O looking symbol is our standard deviation. So put in the mean of 40 for this set of data, and the standard deviation of 10. And then from there, we can work out what the probability of a certain set of data is between certain boundaries. So for the lower and upper boundary, we're going to be using the lower boundary of 37 and the upper boundary of 48. So pop those values in, lower value 37, upper value 48. You can just hit execute and it'll give you the probability there, but I actually like to draw it. So if you head down to execute and ask it to draw it for you, you can actually see, because sometimes it actually asks you to illustrate your answer, which I've done here, but you could just copy this image here. Here it doesn't have the mean and the increase or decrease in standard deviation. It's just got 1 standard deviation, 2 standard deviations, 3 standard deviations above. Anyway, that's sort of the same section we're talking about, and the probability is 0.406. So the probability that a randomly selected radish will be between 37 and 48 grams is 0.406, or we could say that 40.6% of the radishes are between 37 and 48 grams. Now, don't get too caught up on whether you're writing it as a decimal or percentage. Either should be fine if you're working with the probability here. But for me, I'm just going to leave it as a decimal. P equals 0.406. Okay, so I'm just going to remove that red line from the red shading from the graph. I'm going to change my color to green because the next question we're looking at is what is the probability that a randomly selected radish or a random piece of data is greater than 45 grams. So on my graph, I'm looking at sort of this section here above 45 grams. You notice again, that's not exactly on a standard deviation boundary. So we're going to use our calculator. Now I don't have two values. I've just got, I guess, in this case, I just have a lower boundary, you can see, okay? So what I'm going to do is I've still got my mean there of 40 and my standard deviation there of 10. It hasn't changed for this question. I'm just going to change my boundary. So my lower boundary is now 45 grams and my upper boundary is not given to me. So I'm just going to make it a really big value, okay? So make it as big as possible. I just press 1 with a heap of zeros after it. It'll change it to scientific notation, which is fine. And then when I've done that, again, ask it to draw it for me. I can see the section that I've shaded is the same as what we're working with in the calculator. And the probability is 0.3085, or I'm going to round it up to 0.309. So the probability that a randomly selected radish is above 45 grams is 0.309. Or if you're looking at it in terms of percentage, 30.9% of radishes are above 45 grams. The last question there is similar to that one there, but this time you'll see that we're actually looking at what's the probability a randomly selected radish is less than 26 grams. So again, we're talking about from here below, which again is not on a standard deviation boundary. So on my graphics calculator, I just changed those boundaries. I've still got my mean of 40, my standard deviation of 10. I'm just changing my upper and lower boundaries. This time my upper boundary is given to me. My upper boundary is that 26 grams. So that's the value there, 26 as my upper. My lower boundary this time we have to make really small. Now make sure you put in a negative here. So minus 1 with a heap of zeros after it. And that will make a really small value. So no radish will, well, no radish should weigh a negative value anyway. But just get in the habit of writing your lower boundary as a negative and your upper boundary as a really big positive value. So once I've got that in, my lower and my upper boundaries, my standard deviation and my mean, I can ask it to draw it for me and determine the probability, in this case, that a randomly selected radish is less than 26 grams is 0.080. So probability is equal to 0.080, or that says about 8% of radishes weigh less than 26 grams. All right, so that's it. Hopefully that helps. That's how to use your graphics calculator when questions about normal distribution and probability or percentages aren't exactly on those standard deviation boundaries.